Hello everyone! Today I'll tell you about one unusual object, the paper clip. This clip is made from a very unusual material, nitinol. Nitinol is an alloy of nickel and titanium in proportions of 45% titanium and 55% nickel. This alloy has a unique property that was discovered in 1961 by American scientists. The property of this alloy is called shape memory. So, to demonstrate this property, let's conduct an experiment. Take a clip of nitinol and deform it. Besides the clip, I as well have a spring made of nitinol, which I also deform into a random shape. The activation temperature of nitinol is about 40 degrees Celsius. I have turned on the burner on the stove and put the deformed nitinol clip on its surface. Over time, while heated, the clip begins to return to its original shape. The same thing happens with the spring. This happens because when the temperature changes, the crystal lattice configuration of nitinol changes from one phase to another. Also, nitinol is 10 times more elastic than other metals. While nitinol restores the shape, it can also do some work. Let's see what kind of work a small spring of nitinol can make. I have attached the spring to a tripod and hung a porcelain basket onto it, which weighs 180 grams. Next, we stretch the spring. For the spring to be tightened again, I'll heat it with a lighter. Let's proceed. As you can see, the spring has left the basket quite easily. Now we'll complicate the task. I'm adding metal bears into the basket, and the total weight now becomes 278 grams. Testing the spring. As you can see, the spring can easily handle that task. Adding more weight. I now put the stone and a piece of pyrit into the basket. Total weight is now 414 grams. And as you can see, nothing can stop the power of our spring. In order to ensure how big is the power that nitinol creates when restoring the form, I hung a YouTube silver button on a spring, which weighs about 1 kilogram. Trying again with heating the nitinol, and what we see is even this huge weight can be risen by the spring very easily. However, you could now probably ask, if it's such an amazing alloy, why don't we use it in our everyday life? The main drawback of nitinol is its high price and the complexity of manufacturing and welding. In the 70s, experiments were carried in the United States on engine models based on nitinol and its properties. However, it hasn't gone further than the prototype stage. The statement of US leadership of disadvantages of the project became the reasoning to reject this idea. Today, nitinol is mainly used in medicine for bone bonding. Who knows, maybe in the future when the oil runs out, humanity will revert to the nitinol engines.
A small piece of sodium metal is placed in a flask containing yellow chlorine gas. The flask also contains sand to prevent the heat which will be generated by the reaction from cracking the glass. Initially, no reaction is observed between the sodium and the chlorine. The reaction will be initiated by adding a drop of water to the sodium.